All right, so take a look at this. P sub n, this is just capital N instead of lowercase n. That should not make any difference. 380 times 1.08 to the nth power. Now notice here, n, the variable or the number of years or the time n is in the exponent, right? And every time you see this number as an exponent or as a part of the exponent, right, you know it is an exponential growth. In fact, it's called exponential growth because of that fact. The number n shows up as an exponent, exponential growth. All right, exponential growth at rate of what, 8%. Okay, and that's 0.08. And that's why this is 1.08, because when you add 100% to 8%, of course, you have 108%. So the initial population in this case is 380. Okay, so P sub n is P naught is 380, and it's growing by 8%. The second growth, notice here, this n is not a part of an exponent, and it's simply 300, which is, slope times n. And so this is linear growth with the d, the difference of 300. Every year, this grows by 300. And the initial value in here is 4,000. So the current population is 4,000, and it's growing by 300 per year, for instance, if n is the number of years. All right, this third one may look slightly different. P sub n is n to 2 to the n. Now remember, n is the exponent, so this is called the exponential growth, but it's a specific type of exponential growth, 2 to the n. So here, this one grows like this. We'll talk a lot more about this. We have many examples of this in just a little bit. This is n, this is 2 to the n. When n is equal to 0, oh, you know what 2 to the 0 is? 2 to the 0 by definition is 1. Okay, it's not 0, it's 1. There is a reason. There are many reasons for this. We will not get into it, however. 2 to the first is 2. 2 squared is 4. 2 cubed is 2 times 2 times 2 is 8. 2 to the fourth is 16. 2 to the fifth is 2 times 2 times 2 times 2 times 2, which is 36, and so on. All right, so this is called, naturally, doubling, because you can see that these numbers double every single time n increases, right? We will look at a couple of stories in the backs or on the worksheet. Maybe you'll see them on quiz, and I will make some comments on this. All right, the rest of this is going to be an application of what happened recently in the COVID-19 crisis. So if you remember, I hope, well, you may still remember this, back in the spring of 2020, in fact, about January of 2020, we started to hear, that's the month, by the way, Kobe Bryant passed away, right? And by that time, we were starting to hear, I mean, that was great, big, huge news story, right? The former basketball star Kobe Bryant tragically got killed by a helicopter accident. And then you thought maybe that would be the biggest news story of the year. Well, it turned out 2020 was very, very packed with news. And so in the spring, early spring, we started to hear about this thing called coronavirus. Okay. And in fact, there are many types of coronaviruses, but one particular one, a new one, is called the new coronavirus, later identified or named as COVID-19. And the number of COVID-19 patients in the US started to grow rather sharply in March of 2020. All right, and these are some of the data that I collected from the CDC website, along with some other news websites. And by the way, these numbers sometimes change because they noticed that there were some errors and so on. But these are fairly accurate numbers. And again, these are the confirmed cases in the United States of people infected with COVID-19. On March 1st, there were 30 cases. On March 15th, which is 2 weeks later, the number became 3,487. And then by the end of March, there were 186,000 people. And by the middle of February, April, we had over 600,000. Okay, so what happened? I wanted you to focus on this 2 week period. Okay, now after all, we have like over 330 million people living in America. These are extremely small numbers compared to 330 million. Why were there such drastic measures taken just around March 14th, which I remember was a Saturday? I was out with my friends, and that was the last time I had sort of a social time until the pandemic was over, or almost over. But March 15th then was the Sunday. Okay, in this 2-week period, what happened, and why did public health take such drastic actions, like as a closing and shutting down everything? All right. So based on the first 15 days of March, the number P sub T, T is the number of days, okay, where T is 0 corresponding to March 1st. Okay, so this is where T is equal to 0. So let's see what happened. Let's see if we can model this by exponential growth, because this was very much a type of an exponential growth. Right? P sub T of infected people, the number of infected people in the United States, roughly followed. And again, I am using these two numbers. Okay, based on these two numbers, if you were to put this in an exponential model, you have this equation. P sub T is 30. Remember, this is the initial number, initial quantity, times 1.4045 to the Tth power. Okay, so this is the equation we are going to go by. Let's fill in the blanks below here. Okay, T is equal to 0. This corresponds to, of course, let's go ahead and calculate this. Oh, by the way, so this is where T is equal to 0, right? Now this, because this is 14 days later, this is T is equal to 14. Right now, 31st, remember that's 30 days after March 1st. And so this is 15 days after that. So that's 45. Okay, we have T is equal to 0, 14, 30, and 45. Okay, so now let's go to the chart, March 1st. All right, so the equation, of course, is based on this number, this date, and this date. So what I'm saying is that these two dates, the numbers will be exactly these numbers, okay? Because these are the two numbers that this model is based on. So P sub 0, of course, this will be 30 times 1.4045 to the 0th power, which is simply 1, and so that's 30. And of course, actually, there were 30 people, and so that's because one of the data point on which this number is based on. Okay, so that's no problem. It's not what I'm saying is it's not a surprise that this number is the actual number. Now, if you take P of 1, which is supposedly what the model gives as the number of infected people as of March 2nd, this would be 30 times 1.4045 to the 1st power, and this will be about 42. Sounds like a famous novel and a movie. The answer is 42. Okay, actually there were 53 people, so the actual number turns out to be much bigger than what the model tells us. Okay, P2. This is the second day, right? So this is 30 times 1.4045 square, and this is approximately 59. In the actual data, according to CDC, we had 80 people by that time. March 15th, this will be P of 14, right? Because this is 14 days after March 1st. So this will be 30 times this number raised to the 14th power. And so this is approximately 3487, and which is exactly what this number is here for the actual. And that's because, again, this is one of the two data points used to come up with this equation 1.4145 as my base for the exponential growth, right? So again, this number and this number are actual data because the model is based on this. But let's go to find what happens when T is equal to 30. That would be March 31st. Okay, so this would be P of 30. And so this is, again, 30 times 1.4145. And then you multiply raise it to the 30th power. This turns out to be 799,417. I would encourage you to go ahead and do this calculation on your own. Actually, it's getting more crowded. Let me go ahead and erase this and rewrite this without all the details. So if you calculate this, it becomes almost 800,000. Okay, and then by mid-April, April 15th, this will be P of 45. Okay, so what you do is plug in 45 for this number here. If you calculate this, this would have been 130.5 million. All right, now these are the values predicted by the model, okay, assuming that nothing is going to be taking place. If there's nothing to inhibit or slow down the growth, the rapid growth of COVID-19 infection, theoretically, these are the numbers we would see on March 31st and April 15th. Well, we didn't see these huge numbers within such a short span of times. The actual data for the end of March was 186,101. Now that's a huge number, but that's nowhere near 800,000 predicted by the model. The actual data as of April 15th was 362,548. Now you can look at these numbers at the CDC website. Also, Johns Hopkins University in Baltimore has a very well-known medical school, and they also published very carefully studied data. Okay, so what is this saying? Is this saying that the model was wrong? Because these numbers are quite different from the from the model predicted by this equation, right? No, the answer is that something was done right around here. Okay, so if you remember, I mean, this is around the time when the stores shut down, the businesses shut down. You were asked to stay home and stay safe. Safer at home was the chant of the government agencies and so on. And based on what was done in the society, okay, we saw a significant slowdown here. Now, back in chapter 5 and in chapter 1, we found that observational data or observational studies, correlation, association can never emphatically or definitively imply causation. Remember, correlation does not imply causation. So just because we see the slowdown does not guarantee that the measures that we took as a society contributed to the slowing down of it. But this is a drastic slowdown, right? In other words, there was a huge difference between what we were seeing in the first 2 weeks, right here, as opposed to what happened later when the mask mandate was implemented and the staying at home, the lockdown was implemented. Right, so there is strong evidence that this actually at least partially worked, right? But take a look at what we were seeing, or more importantly, take a look at what the health officials were seeing in the first 2 weeks of March. Okay, this is the formula that they would have come up with looking at these numbers just on the first 2 weeks, during the first 2 weeks of March. All right, so here are the questions, the real important questions. And in a sense, you can say these are like, life and death matters, right? Because people really died many people died. In fact, hundreds of thousands of people lost their lives due to COVID-19. All right, so if you are one of these officials, and if you notice this exponential growth on March 2nd, and if you told everybody, look, this is terrible, how many people would be infected by end of March? You'll say, look, based on our calculation for the first 2 weeks, by the end of March, you're going to have 800,000 people infected by this new coronavirus. What reaction do you think you would have gotten on March 2nd? All right, so if you look around on March 2nd, there were 53 people in the whole country with this infected with this virus. Okay, 53 in the whole country. Most people will not listen to you very seriously and say, yeah, sure, what's for dinner? Okay. On March 15th, though, this is only 2 weeks later. Okay, now you only see about 3,500 people infected. Again, in the whole country, 3,500 infected people in the entire country is not a large number. But you, let's say, a scientist or a biologist or a doctor, whatever you may be, noticed this exponential growth, and you came up with this equation. You noticed that numbers went from 30 to 3,400 or 3,500 in 2 weeks. You came up with this model, which would tell you that by the middle of April, the country is going to see over 130 million people infected. This would have been a serious concern for you. And then on March 15th, with the 3,500 people infected with this in the whole country, some cities like LA, San Francisco, implemented partial lockdown. Was this a good idea? What if nothing had been done? So the answer to this last part is easy, because we have the answer. What if nothing had been done? If nothing stopped the growth we saw in the first 2 weeks of March, this is the number of Americans who would have been infected. Now, no, I'm not saying this many people would have died, okay, because many people did not lose their life just because they got COVID. But the number of people infected with COVID-19 would have been over 130 million people if nothing had been done. Okay, so let's go ahead and summarize what we have been saying here. For this, I'm going to write the answer. What do you think people would have said if on March 2nd you warned the whole country that this is a very serious thing? And in fact, some people were saying this. Look, this is no joke. Okay, this is coming, and health officials were sure that this will be a major illness. Most people actually did not take it seriously, because to them, okay, so on March 2nd, only 80 in the country were infected. So most would not have believed you if you had told them that about 186,000 people would be with the virus by the end of March. Okay, they would have just sort of not believed you. So yeah, by the end of March, you're gonna have over what, 186,000 people getting sick. Yeah, right. We only have 80. Okay, but this underscores the fact that we really need to understand exponential growth. You see how serious this is? Okay, if the society as a whole understood the exponential growth, I think more people would have been a little more careful about what happened. Okay, now on March 15th, again, only about 3,500 infection cases in the whole country. People thought this was just ridiculous that major cities were doing partial lockdown. Okay, but here's the fact: if nothing had been done, and the number continued to grow exponentially, by mid-April, about 130 million people. Oh, by the way, that's over 1/3 of the country would have been infected, but instead only 600,000 were. So therefore, it was probably a good idea that health officials took these drastic measures to slow down the process. After all, it's their job when they see a number of the amount of increase or the level of increase like this. What this, by the way, is saying, did you understand what this is saying here, or this is implying? This equation implies that there was a 40% increase every single day. Okay, that's what that 1.4 is indicating. T is the number of days. All right. So for the first 2 weeks of March, the health officials and public health people actually saw a 40% increase in the number of cases every single day. And with that rate, they were afraid that in 6 weeks, 1/3 of the population would die. And in fact, I mean, would be infected with COVID. And in fact, by the end of April, the entire country would have been infected with the coronavirus. And therefore, the drastic measures were taken. Okay, so I hope you will see the seriousness or the importance of knowing and studying exponential functions. Now, you may not be doing this kind of calculations, but I do want you to see this, and I want you to remember exponential growth is something to worry about, okay, or something to keep in mind. All right, so we have a couple of questions on the quiz. The first one is a question about you spreading a new religious or starting a new religious movement, okay? And if the numbers double, the exponential growth would quickly overtake the world. And so that would be the story. Second one is similar. If you have a magic penny that grows and doubles in number every day, what's going to happen? And the story number 3 is also similar. They all have to do with doubling or the doubling equation. Number 3 is about a bacteria or bacterium that splits and doubles every minute. Okay, so you should be able to do these problems. I hope you will, and go dive into quiz for section 6.1. All right, that is our lesson for section 6.1.